Let's dive into the architectural observability cycle of a Java monolith. This is the architecture of a simple ordering management system application observed by vFunction. The bubbles represent domains that were identified by vFunction using its proprietary AI. The size of the bubbles represents the size of the domains by number of dynamic classes in them, and the color represents the degree of modularity of those domains or the class exclusivity in each domain. Dotted lines between domains represent calls between them. Solid lines represent shared resources. For example, beams, synchronization objects, transactions, database tables, and more. Standing on a solid line that connects two domains shows the shared resources between them. There is a lot more information that the system visualizes, for example, the full call tree of each of these domains and many other parameters to understand the architecture of the system. In this demo, we want to focus on three sources of architectural technical debt in this application and how they are prioritized and addressed. First, we want to set priorities and business goals for some of the domains. Setting these priorities and goals allows the system to prioritize the architectural technical debt events and the to-dos to address them. We can set the product domain as having the highest priority and the improving resiliency as the primary business goal. We could also set a target cloud environment for it if we are looking to deploy this domain as a service in the cloud. We can set the ordering domain as having second priority with scalability as its primary business goal. Just from the visualization of the architecture, we can see a dependency between the product and the ordering domains. Such dependency impacts resiliency. If we look at the to-do list, we see that indeed this domain dependency comes as prioritized at the top of the list. If we look at the second issue, resource exclusivity, we see it impacts the ordering domain's scalability. A good way to understand this is to go to the resources report and see the database table's relationship to the domains. Indeed, we see that the order line table is accessed by three domains for both read and write operations. This dependency obviously affects scalability and resiliency. The third issue I would like to focus on is the high debt class, which is a class that has high number of dependents and dependencies. We see that the product service class is a high debt class. That is a source of technical debt that needs to be addressed. To sum up, we have seen three sources of technical debt and how they were prioritized. The list of to-dos can be exported to Jira or other systems, and some of the to-dos have assisted remediation with AI. For example, high debt classes can get a very detailed prescribed remediation using ChatGPT. Now let's move to configuring the observability cycle for this application. First, we see the list of architectural events that are relevant to a monolithic application that we want to observe, from domain changes to dependency between domains and cloud compatibility. Then we set this architecture as a baseline against which we will measure any drift or changes, as well as set the CI/CD as a trigger to initiate learning, so for each release vFunction will learn the architecture. Let's fast forward 2 weeks and see how this application looks like after several releases. As can be seen, we have new domains, colors, and dependencies. Some of the to-dos have been remediated, for example, the sales order database multi-domain dependency. We can also see that 2 new domain dependencies have surfaced and a new domain, delivery, was added. This represents the architectural drift that vFunction is identifying. It observes, analyzes, and visualizes the architecture and identifies sources of architectural technical debt. It helps remediate those issues, and it observes how the architecture is evolving from release to release.